Hello! So this is a slightly unusual video and I'm going to tell you a story about playing a small prank on a coder and a self-proclaimed greedy musician. And it all started on the 22nd of January, listening to Unstable Radio on DJ Hoffman's Twitch channel. Towards the end, he played one of his songs, The Shipping Forecast, and this is what he said.
I said it once, I'll say it again. This sample here. When you go to a demo party with that tune, that's on the coast, I kept hearing that seagull all weekend, and it sounded exactly the same as the sample that I had. My mind was broken by the end of the weekend.
And that gave me an idea. However, there were several iterations of this project before it worked 100% properly. At the time, with the Amiga Kickstart event being later that year, I wondered if it would be possible to buy a soft toy seagull and embed some electronics inside, so when the seagull was moved, it played that seagull screeching sound, just like from the music. So I started by using one of these greetings cards modules. They're easy enough to find. You simply press this button and record your sound. And then you press this button to play it back. You simply press this button and record your sound. Simple. I isolated the sound I wanted and recorded it from the original mod file by muting the other channels, and by holding the device to the speaker, I recorded it. Now happy with the sound, I disconnected the recording button and the microphone so there was no chance of accidentally recording over it. To trigger the sound, I wanted to use some kind of vibration sensor, and I had a lot of these around from a previous project. They're not that sensitive, unfortunately. Sometimes they require quite a knock to get them to detect it, as you can see here. The pulse is also very short, not really even enough to light an LED, although this won't be an issue. So I wired one of these up to where the play button should be. First, I'll short out the switch so you can hear the audio does actually work. But then, no matter how much I flick and knock this switch, nothing happens. And what's worse, if I try now to play the sound again, by shorting across the contacts, nothing happens at all. It's actually not even responding anymore, needing a power cycle before it actually works again. Part of the problem here, I suspect, is the play button also acts as a stop button too. I'm guessing it locked up the chip with all the pulses it would have received from the vibration sensor, so sadly I had to throw that rather neat and potential solution out of the window. But I still wanted to build this, and those of you who've seen my channel before know that I like to dabble with Arduinos. Now my first thought was, what if I connect one of these up to trigger that soundboard? But then I don't want to put a whole full-blown Arduino Uno in this thing, and that seemed well over the top anyway. But then I thought to myself, if I'm going to add one of these microcontrollers, then let's learn something new and have a little bit of fun. I decided to have a close look at the ATtiny microcontrollers, specifically the ATtiny 85. For just a small 8-pin chip, it packs a surprising amount of features, the majority of which we don't actually need, but I've never used one of these before. To help me along, I discovered a version already on a board designed to plug into the computer's USB port, which should make prototyping this really easy. I saw that its input voltage was shown here as 5 volts, but I knew from the datasheet that the chip would actually operate at a much lower voltage, so later I'll probably remove this voltage regulator anyway. But I also need to be able to play sound effects, and there's several modules around that can do this. Now I could add some SPI EEPROM, maybe a D2A converter, or possibly use PWM to play back the sounds, and then maybe an amplifier, but that all sounds like far too much work. Instead, I'm going to use the DFPlayer mini board that can play MP3 files from an SD card. And having used it previously, I know that it works really well. Plus it has a built-in amplifier too, which is probably powerful enough for my intended use. The only problem with all of this is I need it to all run off battery, and I decided on 6 volts using one of these convenient battery packs that takes 4 AAA batteries. This should be fine, as the ATtiny can work between 2.7 and 5.5 volts. So I can use a diode to drop the voltage down a little, and the DFPlayer mini module, well, that claims to work between 3.2 and 5 volts. I'll come back to that in a minute. But the battery needs to last a long time. For the ATtiny, this isn't a problem. In a previous video I showed you how you can put these Atmel microcontrollers into a very low power state, consuming microamps of power until woken up by an external trigger. However, the DFPlayer mini board, when powered at 5.5 volts, consumes around 26 milliamps just sitting there idle, not playing anything and without the speaker even connected. Now I've tried sending the various sleep and standby commands to it, but none of them actually seem to change its usage. And before anyone says it, yes, this is a genuine part. A quick Google shows that an average alkaline AAA battery has roughly between 800 and 1200 milliamp hours of power stored inside. And putting this information into two of the many life battery calculators around, at worst it would run for just over a single day, and that's not ideal. The DFPlayer Mini's power usage isn't actually as much of a problem as you might think, because it's quite easy to get around. Because I can program the ATtiny chip to only power up the DFPlayer module when it needs to play something and control it via a transistor or a MOSFET. Now this actually works perfectly, except for one thing. The DFPlayer Mini needs around 650 milliseconds to start up before it'll actually do anything, meaning there'll be a delay. A little bit of a pain, but I went with it for now. So, keen to get this done quickly, I literally soldered everything together in mid-air, thinking I could just put it all in a box and it would all be fine. I didn't have a lot of time at this point, as I was still building my disc cleaning machine to take along to Kickstart as well. Now as for the code, well, that was actually quite simple. However, the ATtiny doesn't have a serial port, which is needed to communicate with the MP3 player. So, I took a copy of the new soft serial library, and after understanding how it worked, I stripped it right back to only support transmitting, and at a fixed 9600 baud rate too. I didn't want any extra code running that might get in the way of what I was planning. There's not really that much to the code either. The first section just defines the pins used for inputs and outputs, and the rest is stolen from the DFPlayer Mini's official library, because all I need is the play command. And this function actually triggers the playing, remembering to actually power up the device first. I ended up having to wait around 650 milliseconds for the playback to be reliable every single time, and you'll notice it supports 3 different sounds there too. I'll come back to that in a minute. Next up, the all-important sleep function that powers down the MP3 player and sets all of the various bits to put the microcontroller into a deep sleep. There's only a few ways to actually wake it back up again. One of them is to perform a power cycle. One is if it detects a brownout situation, but I plan to disable that later on. And then there's the USI start condition, and finally to trigger an int0 interrupt, which is triggered by bringing pin 2 low. The setup function is much like you'd expect, starting with preparing the port pins. However, I also trigger sound number 1. The reason for this is this particular DigiSpark board waits 5 seconds on power up before running your code whilst it's in the bootloader. This delay is there, so if you plug it in via USB it can be interrupted and reprogrammed. Then it plays this sound, which sounds like this.
Way too rude.
Finally, the first thing it does in the main loop is go to deep sleep. And upon waking, it increases a counter and then plays sound number 2, which is the seagull noise. Now you might notice here there's a special action on the 20th trigger. This was a little Easter egg I added that sadly never got discovered. You'll see why in a minute. So I was happy with it and it seemed to be working perfectly. I stole the speaker from the original module and made a box for it. However, I had a few issues with the speaker drawing a little bit too much power, causing the DFPlayer mini board to reset itself, but a few resistors later fixed that at a slightly less volume. Next up was to cram all of this inside a toy seagull, so I ordered this. And the first thing I did was to cut a hole underneath and sew a zip there. There was just a simple process then of stuffing the circuit inside. The vibration sensor wasn't actually that good, but playing catch with the seagull triggered it just fine, although the 650 millisecond delay was a little bit annoying. So I took it with me to the Amiga Kickstart event and I presented it to DJ Hoffman, who found it very amusing. However, several hours later it stopped working, and when I got it back home, I took a look inside, and it had been thrown around a lot more than I'd imagined. Not only were there 3 breaks in the circuit, but also the speaker was totally disconnected. This was going to need some serious repair, but then it occurred to me I could repair it, but there are several things about this build that I didn't like, not least its durability. And now I had some more time, I thought, why not make a better version 2? The 2 biggest things I wanted to change was, rather than using that little USB ATtiny board, I wanted to actually use an ATtiny 85 directly, which would mean I could get rid of the 5-second power-up delay. Also, I wanted to do something about that 650 milliseconds delay between the vibration being detected and a sound being triggered. You can buy the ATtiny 85s easily enough. They come in surface mount form and dip like these. But to program these out of the box is not quite as simple. Firstly, they come with absolutely nothing on them, i.e. no bootloader. Which means that secondly, even if you did connect it via USB, it wouldn't do anything. As I didn't have a suitable programmer for these, I decided to build my own because it's fairly well documented. You can use an existing Arduino programmed with the Arduino ISP program to program another chip via the ICSP interface. As long as you follow the wiring, programming an ATtiny is just as easy, although in my case I'm using an Arduino Nano instead. It may look a bit rough, but it works absolutely perfectly, and I could easily program it from the Arduino IDE now, and without the usual bootloader the code starts instantly. Whilst looking at the hardware, I decided to try out some of the other vibration sensors. This one is far too sensitive for our use, plus it needs to sit in a disconnected state when it's not got any vibrations. However, this one seems to be a good balance between being very sensitive and the original one. After a little bit of tinkering and playing around, I had this prototype built up and working on a breadboard. Now you may notice I have what looks like 2 transistors, or this time I've switched to using MOSFETs, but why 2? Well, if we take a look at the back of the DFPlayer Mini, you can see there's actually 2 chips there. This one is the actual MP3 playing chip, and this one is actually a small 2-watt Class D amplifier for the speaker to use. According to its datasheet, the amplifier has an idle power consumption of around 8 mA when powered at 5 volts. So if we can power that down, that could be a potential saving. So I wondered, what if I disconnect that chip from the board and power it separately? That would not only allow me to power up the amp at a different time to the MP3 player chip, but also, as they're powered by different separate MOSFETs and with voltage drops and local capacitors in the module, the speaker overloading and resetting the player issue might go away. Now if we take a look at the back where the amplifier chip is and compare it to the pinout, given I'm planning on disconnecting the ground supply to this chip via a MOSFET, there's 2 pins we need to look at. Pin 1 is a special pin that shuts down the chip. However, to shut it down we need to pull it high. Now you can remove this 0 ohm resistor here and move it to here, which will cause the amplifier chip to only power up when the MP3 part's playing. However, I found there seemed to be a small gap between the busy indicator coming on and sound coming out the system, so I decided I didn't want to use that method, but I still need to remove the 0 ohm resistor because I don't want it finding a different ground connection. Now as for the other pin, pin 7, that's the actual ground connection for the chip, and the only way we can disconnect that is to unsolder it from the board and bend it out the way. I'll then need to connect it to pin 1 and then run that off to a separate cable. And if you think that sounds a little bit difficult, then take a look at me here struggling to actually do that. Before I show you the prototype working on the breadboard, let's have a look at the new code, and you'll see I've gotten around some of the problems. The first part looks almost the same as before, except now I'm using 5 I/O pins. 1 to control the MP3 amplifier, 1 to receive the busy signal from the player. Yes, you can do this via the transmit signal, but this is much easier. The original switch stroke vibration pin, the serial transmit pin, and finally a pin to control the power to the actual MP3 player. And below that we have a new variable called sound triggered. Now you may notice a special keyword, volatile. This is important because this variable is shared between an interrupt and the rest of the code, and it prevents the compiler doing some optimizations on this variable which might cause it not to be read or written to properly. I'll come back to this later. Next, we have the play sound function, and it's a lot simpler. It turns on the amplifier, waits a short amount of time for it to power up, triggers the sound, waits 1 second as the busy status doesn't seem to update instantly, and then waits until it's finished playing before turning off the amplifier again. Note that special sleep mode command there. Well, our actual main sleep function has gotten a lot smaller, but it's responsible now for powering down and powering up the MP3 player. But also note that when it powers down it goes into the very low power mode. When it comes out of sleep we change that mode to idle. In idle mode we save a small amount of power, but because we're running off battery every single little bit helps. Setup had a few changes. After configuring all the port pins it disables anything to do with the analog to digital converter. We don't need that anyway and it saves us 4 mA. Below that it configures the external trigger int0 interrupt, which is triggered by pulling pin 2 to ground. This, like the sleep function, also prepares the sleep mode to idle as well. Now when an interrupt comes in, if the ATtiny is asleep it will wake up and then run this tiny little interrupt function. If it's already awake it will run this function again, and we'll keep calling it every time it's triggered. This function sets a variable to signal that it's been triggered. Now if the device had been asleep we wouldn't really care about this variable change, But as you'll see in our main loop function, which calls trigger sound and then sits in a loop and waits for 3 minutes, if during this loop the sound triggered variable gets set, then it plays the sound again, and it also resets the 3-minute counter. Now we could have done this by monitoring the port pins, but we already have this interrupt, so we might as well use it. You'll notice here in this loop that it also calls sleep mode, but it will get woken up 1000 times a second because the Arduino library uses one of the timers to make the millis function work. Now sure, this is only going to be a small saving at this point as the vast majority of the power is being used by the MP3 player, but again, it's still worth having. And finally, when the 3 minutes is up, it goes back into deep sleep. The last function we'll look at, trigger sound, has a lot more in it. I thought I'd add a few more Easter eggs in too, so there's several other sound effects that can get triggered. By default, it plays the seagull sound, but on startup, it now plays this sound. Which I've taken from the start of the shipping forecast mod. However, the 8th time this is triggered, it plays the horn sound from the track, and I'm sure some of you will recognise this. On the 16th play, you'll hear this.
Way too rude.
And finally, after 28 triggers, it plays something special, and you'll have to wait until the end of the video to find out what that is. One final thing was configuring the fuses for the AT-Tiny, the important settings being enabling the divide by 8, making it run at 1 MHz instead of 8 MHz, which saves a little bit of power, and then also disabling the brownout detection. This saves a little bit more. Well, it sounds great, but let's take a look at it in operation. And in this demo, I've changed the timeout from 3 minutes to 5 seconds. So first, I'm powering it on, and you get the lovely start sound. Then, any good vibrations after this produce our beloved seagull. Now if I leave it for, in this case, 5 seconds, watch the power drop from 17 milliamps all the way down to 0. It hasn't actually gone to 0 milliamps, it's just below what this meter's currently able to show you. But note that now, when triggered, there's a small 650 millisecond delay. One quick thing I want to show you is if I go back to technically an earlier version where the MOSFET powers both the amplifier and the MP3 player chip, which I can easily do by swapping it out for one I haven't modded yet, then you start to see some of the issues with this, especially when running off battery. As you can clearly hear, this mod is actually really worth the hassle. And also, whilst I had it set up like this, I was able to test just how low the power could go before it would stop working. Now I can't very well stuff this entire breadboard inside that stuffed toy, that probably would last even less time than the previous version. But before I go any further, I really needed to draw up a circuit diagram. But the problem is, once you've done that with these kind of packages, it's very easy to convert it to a PCB. And before I knew it, I'd ordered 5 of them. This video was not sponsored by anyone. Anyway, 2 weeks later, the PCBs arrived. So, meet the Hoffenator. Well, it will be, assuming the PCB actually works. Oh, and by the way, everything I'm showing you will be available in the links in the video description. One last change, well, I don't want to use this crappy speaker that came with the first module, so I found these little tiny 2-watt 8-ohm speakers. They're a little bit louder and the outer part is actually made of metal rather than plastic. To get the most out of a speaker, you need to try and separate airwise the front from the back as best possible. I printed a small enclosure for the speaker to sit in, along with a piece of foam. Speaking of enclosures, I designed this little box to put the PCB inside of once complete to keep it safe. So, I guess the only thing left is to solder this up and see if it works. All assembled, and well, you heard it working at the end, but after testing it more, I decided that the vibration sensor wasn't as good as I thought. It seems to only react when it detects a vibration in one direction. So I decided to remove it and solder the original sensor back in, which you can see here in this photo. And I stuck it down with some hot glue. After all, we don't want this part falling off. And then I put the PCB back into the box. And speaking of the box, now fully assembled, don't you think it looks pretty great? I thought at this point it would be interesting to see what the actual deep sleep current draw was. So I measured it, and it was quite happily sat around 23 microamps. Now I'm sure that can probably be decreased further, but it's good enough for me, and putting that figure into the battery life calculator now suggests that it would sit idle for just under 4 years. And if you're going to leave it unattended that long, it's probably better to remove the batteries anyway, as we know they sometimes leak. So all I need to do is stuff it inside this seagull, and we're good to go. Of course, all that stuffing adds as padding and it makes it a little bit harder to trigger, but here it is, and it still works. This leaves me one more job, handing it over to its new owner. Now at the time of recording this, at the weekend I'm heading down to Zzap Live in Kenilworth in Warwickshire, and I happen to know that Hoffman will be there, so hopefully I'll be able to pass it on. Well, I'm back, and he really did seem to like it. Maybe a little bit too much, and much to the annoyance of everybody around him, I suspect. Because later that day, he was left all abandoned and on his own outside. Poor Hoffman. I do, however, know that he did discover the secret audio track at around 1:30 in the morning, based on a message I'd received. Well, at least it lasted that long, and if you want to know what that track was, then you'll have to scan this QR code appearing now. I know this video was a little bit more random than my usual content, but I found it lots of fun, and I hope you did too. And if you did, give this video a thumbs up. Thanks for watching, and I'll see you in the next one.
And that completes the shipping bulletin here on BBC Radio 4. On behalf of all of us, I'm Neil Nunes, wishing for you a very safe and pleasant night. Good night.